Now, our next speaker is Tomasz Skowroński. He has been a software engineer for over a decade with experience in a wide variety of systems, from mobile to financial. He is a Java virtual machine languages enthusiast and the application programming interfaces explorer and traveler. Privately, he's a friend of penguins and androids. He likes city bikes. He likes podcasts and audiobooks, and this is really private. He's got one allergy and 2 addictions. He is allergic to Java beans, but addicted to good coffee beans and clean code. And his talk is called Resilience Patterns in Practice. Let's warmly welcome Tomasz Skowroński.
Hello. I should start with some boring explanation, some boring definition from Wikipedia, maybe some quotes from the famous person, maybe some another boring diagram. But instead of that, to explain what resilience is, me and Christopher Nolan, especially for you, prepare over 3 million of resilience examples just in 2 minutes movie clip. Let's check it.
The enemy tanks have stopped.
Why?
Why waste precious tanks when they can pick us off from the air like fish in a barrel?
There are 400,000 men on this beach.
He's coming back round. He's coming back round!
Where are we going? Dunkirk.
I'm not going back.
There's no hiding from this sun. We have a job to do.
If we go there, we'll die.
You can practically see it from here.
What?
Home.
Developers from the British Expeditionary Force, you are here in Dunkirk and you are surrounded by the enemy. There is only one way to survive: the sea evacuation to your home country. There is only one way, but we don't have enough warships and the bay is too shallow. It's time for Operation... It's time for Operation Dynamo. You need to use little ships of Dunkirk, over 850 private boats. They are available to you via Boats API. But please, use this API in a responsible and resilient way. Good luck. Hello again, my name is Tomasz Skowroński, and today I will tell you not only how to survive on the beach or on the sea full of enemy fighters or bombers, but how to survive in a world of resilience patterns. I am a Java developer, so don't be surprised with Java examples of these patterns, but resilience topic is more and more popular. If you heard about resilience, you have to heard about Hystrix, the most popular library in Java. There are more of them, probably for each language. There is also resilience for JS, for JavaScript. So you can find components probably for any language implementation. With Hystrix from Java world, there is one problem. Hystrix is dead. He is no more longer under active development. It is in maintenance mode, and only security patches, if they will be applied. So there is no Hystrix more, but there is Resilience 4J. It isn't official successor from Netflix, but it is even more and more popular each day. Resilience 4J, in contrast to, is very lightweight library. In contrast to Hystrix, it has only one dependency, not three. This dependency is a waiver. It is a functional library for Java, but it isn't part of public API, so you don't need to know or use it. Resilience 4J promotes decorators and functional programming. But even if your software isn't written in this paradigm, it isn't a problem, because it means that Resilience 4Js reuse common functional interfaces, like function, of course, but also supplier, consumer, future, runnable, callable. And what is good, you don't need to implement them directly, because you can provide Lambda or method reference. But let's begin with first component, first pattern. Do you know this feeling when you... Sorry for order. Do you know this feeling when you stay at the end of the very long queue and ask, why does it always happen only to me? If yes, probably you should think about time limiter. What time limiter is? You can think about it as if it were a timeouts factor, because you can apply timeout to probably anything. Why do you want to do it? Because you don't want to wait at the failing forever for no result. But wait a moment. Isn't a timeout exception some kind of error? Do we need timeouts factor? Yes, it is. But let's imagine what will happen if you don't have timeouts. If you have time, you can check and wait and check what will happen. But we don't have time. We can check how it works in practice. Each Resilience 4J component needs three steps from you. That means you need to create configuration like this one. Of course, you can use default values, but it isn't a good way. Even you know what are the default values, probably guys from your team don't know them. So always try to write the values. Like here for timeout, only what we need is a timeout duration. And when we have configuration, we can simply create our component, like here, time limiter. There is our business logic. It do only waiting, 42 milliseconds. And what we do next is to decorate our code with created before time limiter here. And it is obvious then this time is below our settings. It will be successful. In other case, like here, there will be failure. So even there is no native timeouts, for example, from HTTP client, we can add it in simple way. You can ask, what is a try? Try is a monad, like an optional. But in case of error, it isn't empty. It contains the exception, the reason of failure. Why do we use it? Because without it, we need to write code like this. we don't want to do it, so it is better to use try. And from try, we can get the value or the exception. It depends what is inside. This time is also about time, but here now time has different meaning. In case of rate limiter, we also limit the time, but not the duration, but the number of executions. But be careful, not parallel executions at the same moment, only executions at the same time window, 1 second, minute, or even hour. So you can think about rate limiter as if it were a throttling factor, because you can simply apply limitation for number of executions at the same time. What throttling is? Let's look at the picture. There are blue lines on the first plan. There is no throttling, so you can see that the limit is natural. There is no limit. Yes, it only depends on your credit card. But when you apply throttling, there is a limit of 1,000 per each second. So you can be safe. For example, in case of DDoS or any other attack. Let's look how it works in practice. Here we also start with configuration. We allow to only 1 executions per each 2 seconds. And here we apply this rate limiter to our business logic using this method. Here you can see that where is this functional way in Resilience4j, because you can implement any functional interface from this list and simply integrate with your code. And here, as you can see, there are 2 calls, and they aren't at the same time. Yes, they are 1 by 1, but in the same time window. And the first one is, of course, true, but because we allow only to 1 call, the second one is false, is failure. Second example is more interesting. The configuration is almost the same, but here is the difference. There is timeout duration. There are also 2 calls, but let's check how it works. And both are successful. Why? Because we still, even if we still allow to only 1 call per each 2 seconds, let's look here. First call is successful because we allow to 1 call, but the second one was delayed 2 seconds. It is the reason of this timeout. Sometimes we don't want to reject unexpected calls. Instead of them, we can move them to the next time window and execute later. Sometimes it is good, sometimes it is worse than rejection. Retry is also resilience patterns. It is simple like a timeout, but so sometimes we often forget that it is also a pattern. It is simple, but it is tricky because we often forget about good configuration for retry. Retry, of course, repeat failed execution. So if there is successful, there are no more attempts. In other case, there are retry. How many? It depends on configuration. I will say 1, 2, or even 3 is good enough. No more repeats, no more attempts. If you don't want to wait more for, because if something doesn't work, it won't work probably soon. Maybe it will work soon, but later probably no. It is better to reject these executions. Default interval function for Resilience4j, that means function that it's a time between each next attempt is constant, but probably you should think about another function like interval, like expressional backoff. because if something doesn't work after 2 seconds, maybe it is better to check it after 4 seconds and 8 seconds, not 1 by 1 second. You can see it on the picture. In our test, we allow to 3 retries, attempts. As I said, I choose better function for this interval function of time, but there are other of them. Maybe you wanna use some more random. You can of course provide a values like a base value and time between each next. You can write custom function. And what is nice, this retry component can be even smart. That means you can configure, like here, when it should retry. Because, for example, like in our case, when we use both API, that means HTTP client for both API. If we receive 500 or even higher status code from HTTP, it means, there was a backend exception, let's retry it. But if you receive 400 something status code from HTTP call, it is a client error. That means, hey, you sent me a bad request, or you sent me request on not found path. Don't do it again. There is no sense for retry. But there is one status, that means 429. It is using for throttling. So if you do too many requests, server should reject them and send you this request. And it is good reason to retry. Maybe the retry will be in the next time window. So server errors and throttling status, that means too many requests, will be supported by our tests. And our server is just a mock. That means if path ends with 500, we always respond with server error. If path ends with 400, we respond with bad request. And the first example is obvious. That means we try to get our boats. We decorated it with boats with our retry component. But because server always fails, we always receive errors. There is no success. But there was, as you can see, there is only one call. But because of retry, there were 3 tries to get this boat number 500. And there is another exception, another case. We try to get also non-existing boat. But as you remember, in case of 400, we respond with bad request. And because our retry is, let's say, smart, there are no more retries, only one try there was to get this boat. Here, in this example, you can simply see first very simple version of fallback pattern. If you can use a try monad not only to wrap executions and wrap exceptions, but also for this kind of work like this, you can provide alternative value, some kind of fallback. So even there is always error from backend, here we say, in case of error, try to recover, use some dummy default boat. And as you can see, the result isn't null, there is no exception. Bulkhead. But this is my favorite example. What Bulkhead do? It works similar to rate limiter, but instead of time windows, instead of periods, it limits parallel executions at the same moment. So time window is 0. It is commonly used to protect resources, to create a resource pool. What is Bulkhead in reality? There is an example of boat, because bulkheads are used not only in IT, but also in boats or docks. And there is example with bulkhead. You can see that bulkhead is some kind of inside wall to partial protection of all, like our resource pool. Now, please imagine this situation. One boat, 20 people, and only 4 paddles this summer. And now the same, but for people without imagination. The same situation explained by code. There are our constants. That means we have only 4 paddles available. There are 20 people on the boats. And we have 2 methods. Paddle now, when we try to get paddles from the resource pool, use them, wait 100 millis, and return to the pool. And method everybody in the boat, when we create 20 threads, start them at the same moment, and run our paddle now. That means we create 20 tasks, start them at the same moment, and everybody try to get this one of these 4 paddles. So let's see what happened in first naive version when there is no protection. You can see that there were created and executed 20 different threads, and the number of available paddles was not between 0 and 4, but often below 0, what doesn't make sense in real life. If we try to synchronize our paddle now method, here, there will be some kind of protection, but first, there were still 20 different threads, and all try to get paddle and use them at the same time. The number of available paddles was 4 at the beginning and 3 later. Why? Because of synchronization, we allow only to one thread to access our resource pools. So 3 of them are never used. So it isn't good. Let's use thread pool bulkhead. Like in Hystrix, in Resilience4j, there are 2 isolation strategies: thread pool based and semaphore based. Let's use first of them, configure. So we say we allow only for 4 threads because this is number of our paddles. Let's see what will happen. And it doesn't look wrong, because you can see that there are a lot of executions. There are only 4 different threads. They were created, 20 of them, but only 4 of them try to get our paddles. And the number of available paddles is between 0 and 4. What is good? Why do we have too many executions here? Because thread pool bulkhead use queue under the hood, and the default value is too high for us. We can decrease it to minimum 1, but still you can see there are 4 + 1 executions. So maybe semaphore-based bulkhead will be better for this case. And yes, it is the answer. Even though here we create 20 threads and start them at the same moment, because of our bulkhead, only 4 of them, what you can see in logs, only 4 of them are accepted to get access to our resource pool. Okay, fallback. I showed you very simple example of what fallback is, but maybe some more examples will be great. First, this picture, as you can see, if you remember from the movie, Sometimes it is better to receive even a boat that can't swim. Maybe some more like IT example. Let's imagine you are VOD platform. Let's say HBO Go. And if some part of your system doesn't work, then nothing worked. So it wasn't best example of resilience or fallback. Let's imagine you are Netflix and some of your components, some part of your system doesn't work. For example, recommendation service. It doesn't work, but it doesn't mean that you can't display recommendations. You can provide fallback. For example, the list of the most popular movies is good enough to be replaced instead of recommendations. The most of people won't see the difference, and it is better than exception or empty list or some other unexpected result. I will show how works fallback in case of extension for Fein. If you developed for Android, probably you heard about Fein or Retrofit. It is a Java library when you can create HTTP client just from the interface, so in very declarative way. Normally, to use Fein or Retrofit, what you need is to create HTTP client from interface like this. Here is the configuration of the serialization, and here is our interface. So you can see there is no implementation. We only configure what should do call to this method. That means it means get at this path, and the same here. And when we wanna add resilience for J for this, we can do it in this way. That means we can add circuit breaker, fallback, or even rate limiter. How fallback works here? What we need to do is to provide alternative implementation of this interface. So our fallback looks like here. Instead of error or null or null, we provide empty list of boats. Instead of exception, error, or null, we provide some dummy boat, our live raft. And again, our fallback is smart enough. That means we only serve it in case of server error, no client HTTP error. And you can see here, even though we try to get non-existing... and what is the reason to use this extension for Fein or Retrofit? We don't need to decorate each method of this interface. Of course, there can be more than two. We can decorate all API, all HTTP client once, and now each method has a rate limiter, fallback, or circuit breaker. And like in this example, we try to get non-existing boat. So there should be some exception or null, but we can get its name, and it is our fallback value. And there are more of extensions. That means even you don't feel good with decorators and functions, you can use in Spring Boot, for example, the most popular framework. You can use annotations. You can use configuration in static file. Or there are more of them. And metrics. There are free implementations for metrics. They are very important for resilience because you need to know what happen under the hood when you use Retry or other components. And circuit breaker. So if you heard about Hystrix, you can know what circuit breaker is. If no, I will explain. The main aim of circuit breaker is to prevent failing executions. But because we can't know when call is failure, we need to provide some try, and after some time we can decide, okay, our backend doesn't work, it's time to open circuit breaker and stop the backend, open circuit breaker and stop the backend. So you can think about circuit breaker as if it were a failures cache. Normal cache only successes, but circuit breaker works like a cache for failures. So it is opposite of retry, because with retry we do more attempts, more calls, more executions, but with circuit breaker we block if backend after this under this circuit breaker doesn't work. Let's see how it works, but before, let's remember this picture. It is not only logo of Resilience4j, but it is also a diagram for finite state machine, because each circuit breaker is a finite state machine. There are three important states: closed, open, and half open. We start with the top of them, that means close. When circuit breaker is closed, our service behind this circuit breaker works in normal way, like without circuit breaker. So what we have here? We have our server, our bots API. We create a circuit breaker here. I will back for details of this configuration later. And this line is interesting. Each Resilience4j components provide not only metrics for free, but also emit events. And these events you can use for more metrics, but you can use them also for example, for assertions in test or for logging. So we collect our events, and then we can verify what was the history of this circuit breaker in assertions. And here we try to get our bots, decorate it with circuit breaker, and call a lot time. We call our decorated method with circuit breaker 10 times, wait some short time, and call it again 4 times. So what will happen? Because our server is mocked, it always responds with error. So you shouldn't be surprised. There are only error answers from this backend. After 4 calls, our ring buffer in closed state is full. This is from our configuration. We decide that 3 is enough to decide does our server work or no. In reality, of course, it should be higher value, like 100, maybe 1000. It depends on the traffic. So when the buffer is full and when there are more failures than successes, default threshold is 50%. In our case, there are only errors. So our circuit breaker moves from the closed state to the open state, the second one. And in this state, when circuit breaker is open, no more calls are permitted. Everything is rejected. No any call won't reach the backend. And how long? It depends on configuration. After a short time, our circuit breaker switch to a next state. That means half open. And in this state, we allow 2 checks. That means 2 next calls are permitted. And why? Because we want to check does our backend behind this circuit breaker work again or no. But because in this test our server always responds with error, our circuit breaker switch again to open state, and no more calls are permitted. So we were here, and we now are here again in open state. So, as you remember, there were 14 calls to our backend via circuit breaker, but only 6 of them were permitted. The rest of them, after some time, after when we had enough knowledge to know the backend is disabled, should be disabled, rest of them were rejected. Only 6 from 14 calls was permitted. Why do we need circuit breaker? Let's imagine if our backend doesn't work or some external servers, probably it needs some time to recover. Maybe load balancer needs time to switch to another node. Maybe some service should be restarted. More calls, especially one by one, isn't best to solve this problem. If something doesn't work, we need to decide, do we want to use retry and try again, or maybe we want to prevent unexpected calls when something doesn't work and use circuit breaker. There are 2 different ways to handle this problem. Cache. Cache is also supported by Resilience4j. Of course, there is no new implementation of any cache. Resilience4j use common definition, so we can provide any of this or another cache. I won't show you how cache works because it is obvious and everybody knows. Even though naming and cache validation are the most hard things in IT, what I want to show you is how you can connect more components. Let's imagine we have not only circuit breaker, but also retry and cache, and how to connect them. First, you can nest everything. It looks like advanced solution, but it isn't. It is very unreadable, so don't do it. You can write everything explicit. We have our method call to our getBoats from our API. We decorate it with retry. We decorate it with circuit breaker, and we decorate it cache. It isn't bad, it isn't bad idea. Because everything for Resilience4j is a function, so we can use compositions and each next layer, each next decoration compose like a next function, and at the end apply. Or we can use some decorators builder and add each component line by line, and it is probably the most clear and best solution. What is interesting, even we apply with this order, that means we add retry, circuit breaker, cache, the order of execution is in reverse order. That means first we check is any value in the cache. Later we check what is the state of circuit breaker. Then we check should we retry or no. And at the end there is a call for our API. You can think resilience patterns aren't too hard, because they aren't. How they work is simple, what I showed you. Topics is, I would say, interesting but simple. It is simpler, of course, than 8 days of Dunker evacuation. But it is only because, first, I showed you only some basic resilience patterns. There are more of them. And probably you can and I'm sure you can use them not only on code-based layer, but also on higher layers of your systems like containers, service mesh, API gateway, or even cloud platform. And what is more interesting, okay, they are simple, but only because the question doesn't sound how they work, but when to use them and how to connect them with your system, how to connect them with other components. What should we remember after this talk? Nothing from this list, but it is good to know that the shortest boat used in Dunker evacuation in Operation Dynamo had just 5 meters. So what should we remember from this talk? First, don't apply every pattern, and not especially in wrong order. For example, let's imagine what will happen if we connect retry and circuit breaker. It doesn't make sense. Don't decorate everything. Not because you can also use annotations or because you can use extensions for some library, like in this Fein example, but because sometimes it is better to fast fail than fail safe. Sometimes it is good to see then something doesn't work. Not from logs, not from metrics, but from UI. From a user point of view, it is better to know when system doesn't work. Fallback isn't a universal answer or circuit breaker. And use metrics, but not only because they are for free, not only for colorful dashboards, but because you need to know your production. You need to know values of throttling. You need to know mean value of retry. Why? Because you need to tune your resilience configuration. And even my examples were related to HTTP client, this both API example. It doesn't mean that resilience is only for HTTP clients or REST. Almost everything what is unpredictable, what is unstable, everything what depends on time, file system, network, or threads is a good candidate for a resilience protection. I'm waiting for your feedback on the conference website. There are 2 more action buttons for you. And it is all from me, just 2 words at the end. Developers, please forget about Agile, just be resilient. Thank you.
Thank you.